All right, welcome back. So we use it every single day, right? But have you ever, really stopped to think about how the internet actually works? No, seriously, think about it for a second. You click a link and bam! A website from halfway across the planet just appears on your screen in less than a second. It honestly feels like magic. But it's not. It's one of the most amazing pieces of engineering on Earth. So let's pull back the curtain and see how it all works.
Okay, to really get this, we're going to use one simple analogy for this whole explainer. Just forget about all the complicated techie stuff for a minute, the code, the computers, all of it. Instead, I want you to imagine the entire internet as just a giant, super fast postal service. Seriously, stick with me on this one. If you get this postal service idea, everything else is going to fall right into place.
All right, let's start the journey. And it begins right where you are, with your device. Think of this as the local branch, the starting line for absolutely everything you do online. It's your personal digital post office.
Okay, so here's the first weird thing about this postal service. When you send something, let's say a request to see a website, it doesn't go in one big envelope. Nope, your computer or phone actually chops your message up into thousands of tiny little pieces. We call these data packets. A great way to think about it is like taking a really long letter, and instead of putting it in an envelope, you write it out on 1,000 different postcards.
So who's handling all these little postcards? Well, that's your internet service provider, your ISP. You know, companies like Comcast, Verizon, AT&T. They are the local post office in our analogy. They're the ones who collect all your outgoing packets and deliver all the incoming ones. They're basically the front door between you and the rest of the entire internet.
Okay, so our little digital postcards are all bundled up at the ISP, ready to be sent. But, where to? The internet is huge. We're talking billions of destinations. How on earth does your packet find the one specific place it's supposed to go?
And that's a real puzzle, isn't it? Because you type in something simple, a name like theexplainer.com. But computers, they don't speak English. They speak in numbers. So there's this translation gap. There has to be something that acts like a translator, right?
And you'd be right, there is. It's called the Domain Name System, or DNS for short. The easiest way to think of the DNS is as the internet's gigantic instantaneous address book. Its one and only job is to look at the human-friendly name you typed and translate it into a computer-friendly number, an IP address.
And this slide shows you exactly what I mean. You type in theexplainer.com and the DNS instantly goes, oh, I know that one. You're looking for 192.0.2.146. Just like that. And now, finally, our little packets have a real numerical address stamped on them. They're ready for the next leg of the journey.
So, our digital postcards are addressed, they're stamped, and they are ready to go. Now the fun part begins, the packet's grand tour across the web.
See, the internet isn't like one long road. It's this unbelievable web of connections. We're talking underwater fiber optic cables, satellites, the whole 9 yards. And at every intersection, every junction in this web, there are these amazing devices called routers. In our analogy, routers are the mail sorting centers. They're the ones looking at the addresses and directing all the traffic.
And the process is just brilliant. Look at this. Your packet leaves your ISP. It zips over to a router. The router takes one look at the IP address and says, okay, the fastest way to get there is that way, and boom, it sends it to the next router. This happens again and again and again. And here's what's so cool about it. The system is super resilient. If one of the roads is blocked, maybe there's too much traffic or a cable got damaged, the router doesn't panic. It just sends your packet on a different route. It's constantly making these split-second decisions to find the best possible path.
So, after hopping between who knows how many routers, all in a fraction of a second, our packets are finally getting close. They're about to arrive at their final destination, the building they were addressed to from the very beginning.
And that destination is something called a server. A server is really just a powerful computer that's on 24/7, just waiting for requests like yours to come in. It's where all the website's files are stored, all the text, all the images, everything. So, in our postal service analogy, the server is the big warehouse that finally receives all of your little postcards.
But wait, the journey is only halfway done. Remember, you didn't just send a letter, you asked for something back. So the server gets all your packets, reassembles your original request, and then it sends a whole new batch of packets, this time containing the actual website you wanted, all the way back to you. And they follow that exact same incredible journey just in reverse.
Let's just take a second and really look at this timeline. From the moment you click
to the DNS finding the address, the packets traveling, in some cases, thousands of miles, the server responding, and then the packets traveling all the way back, the whole thing, the entire round trip, happens in less than half a second. I mean, that is just mind-bogglingly fast.
And keep in mind, this isn't just your one click we're talking about. To give you an idea of the scale we're dealing with, this system handles around 300 billion emails, our digital letters, every single day. The amount of information flying around is it's almost impossible to even imagine. Which brings me to this quote from Dave Barry, which I just love. It's kind of funny, yeah, but it really nails it. This whole system, this invisible dance of packets, routers, and servers, has completely changed everything about how we live and connect with each other. It really is the circulatory system for our entire modern world.
So there you have it, this incredibly complex yet amazingly resilient system working silently behind the scenes, connecting all of us in the blink of an eye. Which, of course, leaves us with one last big question to think about. Since we rely on this invisible network for almost everything, what happens when just one tiny link in that chain breaks?